In this video, we are going to solve Diophantine's equation. A linear Diophantine equation will be of the form ax plus by equal to c, and it is a polynomial equation whose solutions are restricted to integers. It is named after the Greek mathematician Diophantus, 250 AD, and also it is an equation in terms of one or more unknowns which has to be solved. And the solution must be an integer. Like in this case, I have two unknowns x and y, and the solution of x and y must be integers. In order to get the solution, we need an identity called Bézard's identity. Let a and b be two non-zero integers, then we can easily find the GCD of these two numbers and let that GCD be d. We can find a linear combination of this, that is ax plus by equal to d, representing GCD as a linear combination of the two integers a and b. In other words, we can find integers x and y which satisfies the equation ax plus by equal to d. Furthermore, there will exist integers x and y such that ax plus by equal to n. This is only when d divides n. If d divides n, there is a solution. If d does not divide n, then it has no solution at all. Now, in order to find the solution for a Diophantine's equation, there are various steps, and the method is, if an equation ax plus by equal to n is given, then we have to use the Euclidean algorithm to find the GCD of the two numbers a and b, and let that GCD be d. If d divides n, then it has a solution. If d does not divide n, it has no solution at all. Then we can reformate the equations what we get in Euclidean algorithm, and using that we can use substitutions and use the steps of those equations what we got in Euclidean algorithm to get a solution for this equation, and let that solution be xi yi. That is, we are trying to get the solution for this equation axi plus byi equal to d. So the initial solution will be x star y star, which is xi times n by d and yi times n by d. If you are trying to find the general solution to this, then having the initial solution as x star y star, we can get the general solution as x star plus m b by d, where m is an integer, y star minus m a by d. So this is an ordered pair. The x value is x star plus m b by d, and the y value will be y star minus m a by d. So for different values of m, you will get a number of values for the solution. So that will be the general solution to the Diophantine's equation. In order to understand this, let us take this example. Travis is purchasing beverages for an upcoming party. He has $68 to spend. He can purchase packs of cans for $12 or smaller packs of bottles for $8. How many ways are there for him to purchase beverages if he spends all his money? So by taking the number of cans as C and the number of bottles as B, we have to find a non-negative solution to this equation 12C plus 8B equal to 68, because each can cost $12 and each bottle costs $8, and he has got $68 in hand. So the goal is to find a non-negative solution for this 12C plus 8B equal to 68. Now, since it can be reduced, we divide the whole equation by 4, we get 3c plus 2b equal to 17. And hence, we can find the GCD of 3, 2, which is 1, and it divides 17, and therefore it will have at least one solution to this. In order to find the solution, let us proceed further. So using Euclidean algorithm here, we get 3 is 1 2's plus 1 and 2 is 2 1's plus 0, or we can get the GCD of 3 2, which is 1, to be a linear combination of this A and B, which is 3 and 2, as 3 1's and 2 negative 1's. But I need to get this for 17, so when I multiply throughout by 17, I get 3 17's plus 2 negative 17's is 17. So from this, I'm trying to get a general solution with an initial case. So to find the number of ways Travis purchases the beverages, in other words, if you are trying to find all possible cases, we have this equation 317 plus 2 negative 17 is 17, where the 17 negative 17 will be my initial solution for the equation 3c plus 2b equal to 17. So the general solution will be my xi, which is 17, plus m, b is 2, by d is 1, and minus y star, yi, which is negative 17, minus m, a is 3, by d, 1. Or I get that as 17 plus 2m minus 17 minus 3m. But if I want to have positive solution, both x star value and y star value must be positive. So since 17 plus 2m is greater than 0 and negative 17 minus 3m is greater than 0, and we are trying to find an m which satisfies both this result, we get an inequality m lying between negative 17 by 2 and negative 17 by 3. So we need an integer m lying between negative 8.65 to negative 5.65. So when we are trying to look for integers lying between these two numbers, negative 8.65 and negative 5.65, we get negative 8, negative 7, negative 6 as three different values for m. By taking m as negative 8 in x star and y star, we get 1, 7 to be a solution. When m is negative 7, 3, 4 is a solution. When m is negative 6, 5, 1 is a solution. So, if Travis spends all his money, there are 3 ways he could purchase beverages for his party. That is, he can purchase 5 cans and 1 bottle, or 3 cans and 4 bottles, 1 can and 7 bottles. In this video, we try to explain what is Diophantine's equation and how to solve that. And it is an application here. Thank you for watching this video. Hope this explanation was clear to you. And I have put several videos based on this concept, the Diophantine's equations, GCD, and Euclid's algorithm. Thank you for supporting all such videos. Thank you for watching this, and thank you for your patience.